Happy day to you all. This is Orekoya Olusegun Physics Mathematics Fundamental on YouTube channel. Today, we are going to deal with the derivation of the equation of a circle. Now, what is a circle? For us to describe a circle, let's consider two separate points P and Q. Point P is taken to be fixed, that means it's not moving, while point Q is moving. Now, if point Q keeps a constant distance r from the fixed point P as it's moving along a path known as the locus, then that particular path is called a circle. So every measurement you take from the fixed point P to any position of fixed point Q, if you measure that distance between the 2 points, it will still remain as a constant, and that distance is known as the radius of the circle. Now, we now want to derive the equation of a circle. Now, let's consider Cartesian coordinates. Let's have the vertical axis y and the horizontal axis x meeting at the origin. Now, let's take the location of this origin to have a value of x is equal to 0 and y is equal to 0. Now, if we draw a circle around the fixed points OO at the origin, this is a circle. Now, let's take any movable point P on the circumference of this circle, and let this point P as coordinates x and y. What I mean by coordinate x and y is that when you measure along the x-axis, the value you measure is x. When you measure along the vertical axis, that is y-axis, the value you measure is y. Now, if we join a line, which is the radius of the circle, from the center of the circle to the movable point P, let's distance from the center of that circle OO to movable point P of coordinates SY. Let that distance be r. We can see that inside this circle now, we have a right angle triangle. So the circle we are dealing with now is the circle whose center, the center C of that circle, is located at the origin of the Cartesian coordinate system. Now, if we bring this right angle triangle out, we have x and we have y perpendicular to each other, and the hypotenuse of that right angle triangle is the radius of the circle. Now, from Pythagoras theorem, relationship between the hypotenuse is the longest side of a right angle triangle, and is the side facing angle 90 degree. So it has been discovered that the square of the hypotenuse is equal to the sum of the square of the other sides of a right angle triangle, that is x squared plus y squared. So putting everything on one side, we have x squared plus y squared minus r squared is equal to 0. What this expression that we just derived is the equation of a circle center at the origin 0, 0. Now, let's consider another circle that is not center at the origin. Now, let's have the vertical axis. The vertical axis is for the ordinates. We call it y-axis. And the horizontal axis is the abscissa. We call it the x-axis. They intersect as right angle. Now, let us have a circle whose center C is no longer at the center of the circle. Now, let center C be at location A on the horizontal axis and be at a location B on the y-axis. That's the center C. Now, let's locate point P of coordinates xy. on the circumference of that circle. Now, we discover something that the location of that point P along the x-axis is x, which is higher than the value for the x-axis of the center of that circle. Now, then the location of the point P along the y-axis, we take it as y. We discover that that y is more than the y for the center of that circle. Now, if we join the center of this circle to the variable point P on the x-axis, we are going to have what is called a right angle triangle. This is what we are going to have from the diagram. We have this. This is our point C, and this is our point P, x, y. And the distance between these 2 points here on the x-axis is difference between the value of x and the value of a on the x-axis. So we have x minus a. This a is the x value for the center C, and x is the value for the point P on the x-axis. So for the vertical axis, we have y minus b, and the distance between the center of the circle and the variable point is the radius of that circle. Now, from Pythagoras theorem, we have r square is equal to y minus b square plus x minus a, everything square. This is the equation of a circle that has center C located at point AB, which is not the origin. Now, if we expand this expression, we have something like r square is equal to, expanding y b raised to power 2 means you multiply y minus b by itself, then plus you multiply x minus a by itself, and by opening this bracket, we are going to have y square minus yb plus b square. Y square minus 2yb then plus b square. When we open this one, we are going to have x square minus 2ax plus a square. Now, by collecting like terms, we have r square is equal to y square plus s square minus 2ax minus 2by plus a square plus b square. Now, if we put everything on one side of the equation, we are going to have y square plus s square plus 2ax plus minus 2ax minus 2by plus a square plus b square minus r square is equal to 0. Let me rewrite everything starting with x. So I have x square plus y square minus 2ax minus 2by plus a square plus b square minus r square is equal to 0. For us to be able to recall this expression in a better form, we can rearrange this equation in such a way that the look-alike are put on one side. Like for instance, the one that are having square, we have x square and y square, and we have a square and b square. We can put them together, so we can have it as x square plus y square plus a square plus b square, then minus 2ax minus 2by minus r square is equal to 0. So this is the equation of a circle that is centered at an arbitrary point C, which is not located at the origin. Thank you. Please don't forget to share, like, and comment on my video. Again, this is Orekoya Olusegun Physics Mathematics Fundamental on YouTube. Thank you so much for your time. Have a nice day. Bye.